Water is essential for life, but did you know that it also plays a role in global peace and sustainability? Let's explore how UCL studies this important resource.
From access to clean drinking water to extreme weather events like droughts and floods, water impacts everyone. Right now, around 2 billion people worldwide lack access to safe drinking water, and climate change is making water security an even bigger challenge.
At UCL, students and researchers are tackling these challenges, whether it's studying groundwater, improving water management, or even looking at the impacts of climate change on water availability.
So hi, I'm Michel Tsamados. I'm Associate Professor in Earth Sciences. I look at sea ice, the frozen ocean, from space usually, to monitor its changes in thickness and in extent, both for the Arctic and Antarctic. So sea ice has sadly been melting quite dramatically in the last 40 years. I think we lost something like 10 trillion tons of sea ice in the last 40, 50 years. And so that has a big impact. It has a big impact on climate via the albedo feedback mechanism. So as you melt sea ice, the surface gets darker, and as it gets darker, it absorbs more solar radiation and therefore makes the climate even warmer in the long term. But it also impacts Arctic populations. So I work with Inuit people in the north of Canada, and so for them the frozen ocean, the sea ice, is their infrastructure. We have a project with them to try and make sure that this ice is, they can monitor and make their own maps for safe travel on the ice. And obviously they're at the forefront of climate change. Water is obviously critical for them. One more exciting piece of work related to water is monitoring fresh water in the Arctic Ocean. So of course you know that this ocean is saline, there's a lot of salt in it. But in the Arctic there are regions where fresh water in the surface in particular accumulates. And so what has happened in the last 20 years is due to different circulations in the Arctic and also the melt of the water, the fresh water for Greenland, for sea ice, a lot of fresh water has accumulated in the Beaufort Sea, a region north of Canada. And so that 10,000 cubic kilometers of fresh water is important, because if it's trapped there, and when it's going to be released to the North Atlantic, it can really have an impact on the thermal circulation. So that's the global circulation that controls large aspects of our climate. So we are monitoring that thanks to Cryosat-2, which is one of the satellites that was developed here at UCL. And so this is an important part of the water monitoring of our planet.
Hi, I'm David Wilson. I'm a lecturer in the Department of Earth Sciences in UCL. So much of my research is looking at how the climate system has changed in the past. So I'm a geologist and a geochemist and a paleoclimate scientist. So what I do is we go out and we will collect sediment cores or deep sea corals or stalactites, and we can use these to trace changes in the climate system in the past. So one good example of this is looking at sediment cores from offshore of Antarctica. And we can use these to tell how the ice sheet in Antarctica changed during warmer times in Earth's geological history. This can then be useful because it can tell us how Antarctica will change in the future. So Antarctica is a store of a huge amount of water as ice. Something like 60 meters of sea level is contained in Antarctica. So one thing we've been figuring out is how Antarctica has responded to warmth in the past, and we can use this to help the modelers who are modeling how Antarctica will change in the future. And the combination of this geological evidence using measurements in a lab with physical evidence in physical models shows us how sea level will change in the future. So this could be several tens of centimeters by the end of this century, and meters when we start talking about future millennia. And that's really important, because if we have changes in sea level, that influences all our coastal regions, and that influences things like groundwater resources in those regions. Because the salt water can intrude into coastal regions, so that affects things like agriculture or your aquifers that are supplying water to human populations. So that's one really good example of water as ice and its influence on sea level and its influence on resources. So one other aspect of our research is trying to explore how river systems have changed in the past. So we can look at times such as the Paleocene-Eocene thermal maximums. This is warming tens of millions of years ago in Earth's history. And we are exploring changes in erosion, so that's the denudation and breakdown of rocks on the continents and the transport by river systems, and changes in chemical weathering, that's the sort of chemical dissolution of rocks on land. And we have isotope proxies that we can measure in marine carbonates and in sediments from near to the land. And what these help to show us is how in these warm times in the past, so the Paleocene-Eocene thermal maximum was this extreme warming event, we can resolve that the erosion of the land was more extreme, and this related to changes in the storminess and changes in the precipitation. So in a warmer land, in a warmer world I should say, you end up with higher precipitation and often stormier or more variable precipitation, and that leads to much greater erosion and also increases in chemical weathering.
Water is essential for life, peace and our planet. So on this World Water Day, let's appreciate it and take small steps to protect it.